All right, so now for this problem, it says scientists studying biodiversity of amphibians in a rainforest have discovered that the number of species is decreasing by 2% per year. There are currently 74 species, okay, and of amphibians in the rainforest. Which logarithmic function models the time in years it will take um, the number of species to decrease by a value of n? So we, I don't know if I should justify. Remember that when we say we have a total amount, like there's exponential growth, right? And then it would be 1 plus r is raised to the t, right? Um, Remember that that has a relationship, right? So it's like b to the y equals x, and that is the same as the log base b of um, x equals y. So I'm gonna, in other words, I can rewrite this sort of. I'm going to change some of the values, but this is the log. I can model the same behavior by saying the log of 1 plus r, right? And then my t would be like the y, so that would be equals something. And then sometimes this is the rate divided by n. Or I'm sorry, it's the number. Well, I'm just going to write out the formula. So then that is going to be, in this particular case, because you're subtracting, so it would be n divided by the initial amount, sort of. I'm changing some of the variables around, and that would equal the total number t. Okay, so we're looking for something like this. Well, what is our initial amount? Well, our initial amount is going to be 74%. And then our rate is decreasing by 2. So there's two ways that you could look at that. It's really minus 0.02. It's minus because it's decreasing. So then if I write this out, I'm going to say the log of 1 minus 0.02 of n over 74, right? And 1 minus 0.02 is this stuff right here. So D is the answer. And so if I solve for n, we could find it. And I basically, what I don't know if I wanted to do this way or not, but basically the things that I changed, whoops, I probably should explain it because I know somebody's going to ask. If I take A, but I'm going to switch that to n, right? Because that's really what it is the final amount. So we're going to say n is equal to, we'll just call this n naught times 1 plus r, right? Raised to the t. Normally we would do this, divide both sides by n naught. So then I get n naught is equal to 1 plus r raised to the t. And so I'm going to put this in parentheses. So this is like my b to the y equals x. And if you think about that, x equals n over n naught. Y is equal to t. And then my base b is equal to 1 plus r. So then if I write the log of that, I'm going to get the log of my base, which is 1 plus r, of x, which is n over n naught, which is equal to t. So that's how I came up with that. Okay? Well, that's not a good start. We got to draw a better start. Okay, so there's two ways to model growth. Usually we use exponential, but you can also use the log function because of that connection, right? This right here is the same as the log base b of x is equal to y. Those two are the same.